Everybody, apologies for the bad light. We've only got one light up here and it's terrible, so another wee thing to do in the brewery. You'll notice behind me here we have what's lying on the floor is our new panel, and I'm happy to say it is wired up. So this is a video about the wiring of the panel, a little bit about how to solder, which I didn't know how to do before, but now I do. And in the background you can see that all the big pots are gone. Why? Because they're right now in the living room, and I'm going to start to build on the mechanical side of the brewery. So without further ado, here's the video. Cheers. This is the heating element now wired up, and the switch. So as you can see, we have 2.5 millimeter diameter cable coming in for the high current. This flows straight through the circuit breaker, 16 amps rated, and out into a Wagyu clip. And the Wagyu clip is separated into two other outlets. One is 1.5 millimeter squared line for the lower power side, so that is activating the relay and activating the switch. And another 2.5 millimeter cable which comes out and into the relay breaker number 11, the common. Also, contrary to my wiring diagram and video, I don't know why I didn't connect it to normally open, but it should be a normally open switch, which means that the switch in normal circumstances is broken. Now it worked pretty well in the video, but I'm going to have to test that and see does the heating element stay on or not. So that will come during the testing. And then we come out on number 14 and into the first leg of the SSR, and connected in series is the second SSR, and out of the SSR the power goes to the plug. So now we've got to start connecting up our neutrals. So what I've done now is wired in my neutral lines. So all the live wires are in, and that's the orange lines as you can see, and the blue wire, which is my neutral wire, I've just wired. So neutral connected to the plug on the side over here, the red plug. Then we have a Wagyu switch. I had to use a 5-way because we also have the neutral coming off the lamp and the neutral coming out of the relay, but those are both low amp, so 1.5 quadric millimeter wires, and then the heavy duty wire all the way to the heating element plug, and that's this guy here. So the brown wire here, or sorry, the blue wire is our neutral. The neutral feeds the bus bar, this Wagyu 5-way Wagyu clip. The second blue wire feeds directly into this neutral, comes directly out of the heating element plug and into this. Also the neutral from our relay and our switch are wired through, and that will go out there. So as you can see, it's starting to get messy. I'm going to spend a little while cutting the wires down to length a little bit better and tying them off so they're a little bit more organized. Or maybe I shouldn't do that until I test. It's starting to get a bit confusing with all the wires. Basically, what yellow is low voltage, red is for the heating element. And I'm just trying to group all the wires together so it's easier to recognize when I get there. One thing I messed up on the last one is I didn't wire in the key switch. So that is now wired in. The panel still closes, which is good. These little buggers down here on the SSRs, I knew they were going to be a problem. And yeah, it took a good 30 minutes to get in, squeezing them in, but they're in now. I'm wired up to the PID controllers. And that's it. Took in the main power from the living room switch. That's just been tied now into the breaker, and now I'm going to come out the bottom and split the power for the rest of the users. Getting to the point now on this diagram where I have a bus bar, and each DC circuit is fused and the pump is fused. Up until now I was Billy Big Balls and decided, nah, the fuses, I'll be fine. But I'm gonna learn to weld, or not weld, solder, and see if I can solder 3 little fuses in. And just, I've run it down to the bottom of the box, and this is my little distribution here, and just weld to getting 3 fuses like this. Weld them in line, and then they will sit just down here at the bottom of the panel. The reason I was going to leave them out is because I forgot to drill holes for them, but yeah, I'm going to do it. So here's how to learn how to solder. So truth be told, I actually don't have enough brown wire to do all the fuses, so I'm going to wire some green and blue ones on, and then wire the remaining brown onto those with 2 Wagyu clips. So if I do it now, I'll remember, I hope. So I'm just going to strip these wires very quickly. So, what have we got here? I have 2 types of solder. I have no idea which is good, which is bad. This one looks thinner. This one looks fatter. Oh, it tells me in the tin silver. And this one is electronic component, so I think I'm going to go for this one. Just because it says exactly what I needed to do. So I got some solder. It's been a while since I've done this. Of this stuff, which is flux. Now I've tried to solder before without flux. I've tried flux without flux, and I was none too successful. In Dutch, this is solder water for all solder working for great surfaces. I couldn't find any for tiny surfaces. So I hope this does the same thing. Yeah, it's got a nice wee brush in there as well. So give it a go. The solder iron has been preheating. Nice wee LED, and I remember from school I needed a little something for some reason, but I'll figure that out when I get there. And I guess there's a hole in it for a reason, so I'm going to put the wire through the hole.
Alright, maybe like that, like that. So it looks like a connection. I'm going to take my flux. I'm going to flux the shaft. Can I say that this way? Flux the something out of it. And then, no idea, do heat this thing first? But I don't want to, because it's an electrical component, so warm up the solder. I think it was soldering, it could be off everyone to be, oh jeez, okay. Totally holding my breath there because that fumes was so ridiculous. Yeah, completely balls that up. Completely balls that up. But not in a bad way, just in a way. Let's try that again. Well, I'm glad I tried it on these little guys before I tried it on the big fella. Or sorry, big fella, the DC pump. Because clearly I'm a little bit rubbish at it. I can see now that people have those little things where you can hold other stuff. So, a clean. Yeah, that's what it's for, clean. Okay, so we have one. I hope I'm shooting this right. That seems pretty on there. It can't see though. Yeah, it's better. Yeah, it is disastrously ugly, but we got a connection. So, let's try number 2, see if we have more success. I'm gonna do one. I'm gonna do this guy. And I'm gonna see Ben's a little bit. No, he's not doing it. So, get him through. Oh, give him a bend. So you can see he's at least nervous. And then I'm gonna do a little bit of flux the crispness out of them. And then let's see if we can get a more neat and tidy solder. Can you do it? Yes, you can! So I got me one fantabulously ugly fuse job. One done, two to go.
What I was trying to figure out is which is positive, the center or the other. I have no idea. I really couldn't find any good stuff on the internet to explain it. So what I'm going to do is just connect it. I'm going to say that the center is positive and the outside is negative. Cutting wires to suitable length. That fits nicely. So I'm gonna have to be careful because you can see there's a little seal there. But this was pretty inexpensive, so if I mess it up, I'm not so worried. But it'd be nice to get it right first time. Like everything. It just doesn't happen. Like everything. Okay, solder.
I could not be the surgeon, that's for sure. Oh, we got solder stuck to the plastic. There we go.
No, that worked okay. Getting better at this soldering, bad boy. I'm gonna solder. I'm gonna be soldering everything. I'm gonna be going mental with the solder. I've got a few things like my wort chiller to modify. So I'm gonna bend this out a little bit just to keep it out of contact. Now, I'm not sure if you're meant to thread this through, but it seems like a sensible thing to do. And then my port. Yet I didn't know it. Okay. A little bit of flux. So there we go. And then let's solder this little badger on. And then that's soldering done, folks. The excitement is over.
Yeah, that was definitely not the prettiest one. But I see she moves. Yeah, she does.
Okay, so we got our two DC wires. I'll wire them up later. So here we are. This is starting to get complicated. A bit of a jungle here. I can see now why people use the bus bar connections. Yeah. But I think the wee waggy clips do a treat as well, to be honest. It makes it ad hoc wiring a lot easier. And if I make a mistake, just pop it open, rewire. Yeah, it's okay. So, power cable in the way. Get out of the way. Thank you. So, I think we've got most of the lives wired up. Oh, I haven't got the live to my pump done yet. Why? Anyway, I'll figure that out in a second. But as soon as I get my pump wired up with the live, I think we're ready to go and start connecting all our neutrals together. And then last but not least, of course, the earthing. Lovely people. Leaf of Menson. We have a brew panel. It's all wired up. It looks pretty messy. Everything's connected. DC users are connected. Fuses are in. Cabinet closes. I think we've got to test this now. PT100s are installed. I've probably got the longest PT100s in the world. I think these are 5 meters. I overestimated, but no, they can always be easily replaced. So I'm not optimistic. It was a very complicated thing to do, and the more I added, the more complicated. So I expect there's a few flaws. So this will be one of those things, when there's a flaw, I will definitely work backwards. So let's test this. I'm going to close her up now. So before I do this, I would just like to tell everybody that I love them in my life, that is. I died in the name of science and beer brewing, and yeah, it's been emotional. But I'm going to power up one side of the brewery. So I haven't, based on procedure, and I do not advise this to anyone. Actually, I frown upon it myself, and I regret doing this, is installing meal to meal. I tried to think, was there a bad idea? If I plug this into the wall, I have a freaking laser gun here. That is not safe. So I've installed these red things on the panel now, and this was done before I had a fixed brewery, so it had to be a bit portable. What I'm going to do is glue them in permanently. Just whap a bit of glue on here, stick it in, hopefully it'll stick. And on the next brew panel build in 2017, I will make sure that we're a little more safe. So, without further delay, the power is in. Can you feel it? Can you feel it? No, because the other end's not plugged in yet. And we're going to plug the other end. I don't know what position any of the switches are in, so I'm going to have to make notes, swap some wires, I think. Oh my god. Things turned on, things turned on, things turned on. Holy shit, things turned on. Seriously, 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 seriously. Nobody's dead. Nobody's on fire. I've got two different output temperatures for my thermocouples. They're a degree apart. That's surprising. 26, 25 degrees. Nah, give a shit. That's the first thing. But so if I turn this switch, what happens? That's not good. That is not good. So basically, I have power going to my panel, and I cannot break the power unless this is the other switch and I fucked it up. Yeah, he did. Didn't even wire up the wrong switch, dumbass. Anyway, well, that's good. So it's in the opposition. I cannot get the key out. That serves my interlock. So if I turn the panel on, everything initiates. That's nice. And take the key out, then I'm free now to turn on my heater element on, and then I cannot get the key out without turning off the safe control system. So I have two freaking, I've got power. But I'm wondering now, because I wired it the other way around, what's back to front and what's not. I don't hear the fan running, so hopefully all these switches are in the off position. That fan's on. Hopefully that is for, yeah, these are for the two power sockets. Okay, one did not light up. That's not good. But anyway, we'll figure that out. Oh, I think I just blew a fuse. Yeah, I could just blew two fuses. Okay. So the light flicked on, flicked off. Except for Old Faithful here on the right hand side. I've blown every other fuse. I did not trip the main circuit breaker. I still have power to my PID controllers. Don't have any power into this guy because I haven't connected the other power. But I'm going to sort out the right hand side of the panel first. So, that was not a good start. 2 switches switched on, DC, blip blip. And one to the, I can't believe both of them fused out. That's weird. And the other one works perfectly. And the other one shouldn't work just yet. Okay, so I'm gonna have a little look inside and see what went wrong. What went wrong? Okay, I have no idea what happened. I have a feeling these lights blew, but I don't hear any action from the fan. So that's saying there's something wrong with my 12-volt circuit. The heating element is on and the pump is on. Best way to test that is connect the light. That works. That works. Okay, so the heater element and the pump work. That's positive. It's positive. So that means the interlock, these switches are good. He doesn't work now. Oh, because he's not turned on. So if I flick the switch, he turns off. Good. Safety function is still on. Turn the light, flick him off, turn him in, turn him off, flick him off. He is off. So that's good news. Well, not the best news in the world, but something up with my DC circuit. I'm gonna have to look at how I wired my switches, compare that to my old video. Or maybe I wired them back to front or upside down or something, I don't know. But nothing got as close as the fuses were okay. They don't seem to be burnt out or anything, so it seems to me that the switches blew. And I'm very happy I ordered a couple of spares. Oh no, I think I used the spares in my other projects. If I have figured out. My phone died. Yes, it did. But while it was dead, I tested a few things. I went into the DC control system, the little converters, and what I did was rewired the fan because it's really thin wires, and I've also wired up another fan here to just a quick circuit with the plug that I will use for my DC pump, and we'll test that as well. So this little guy goes in here to the DC plug. So let's get this bad boy some power. Rex has come back on again. Nice to see. We got power to the pump. DC fan. Still nothing. Son of a bitch. Test 2. Hey, we got a fan that works. So, diagnosis. 230 volt, 12 volt converter works for this fan. I've rewired the other fan, the one on the side. I rewired that one, make sure it was definitely in there fitting tight. I'm pretty sure it is, so there's no reason, unless like the world's most silent fan. It claimed to be a silent fan, but we'll have a look. There's a peek. Yeah. Now that's what a fan should feel like. So nothing from the fan. Both light switches are out, but clearly this is still acting as a switch, and I'm wondering, Is it just not powerful enough for the amount of current that this little fan takes? I don't think that should make a difference. It's still connected to the neutral. It should take its own current. But they're definitely blowing, the lamps in these. So, pump works. Internal fan does not work at all. Not even constant. And pump works. Pump. Pump. And we know this works. So, I've got to figure out two things. Why are those lights not coming on? Even though this one's working. So clearly there's a current getting through there. So maybe it's something to do with the neutral. Yeah, it must be. If there's a current getting through the two positive terminals, enough to generate enough of the fan, then there's something wrong with the neutral. And it means there's something wrong with the neutral of this. Perhaps, if I look at that. So I'm going to have a little examination. I'll let you know what I find out. Okay, so where are we? Both the red switches that I had are blowing. Fortunately, I had two spare green ones, which I'm very happy about. I've checked my neutral wiring. Seems to be in shape. Maybe there was some sort of shortcut, I don't know, that blew the reds, or maybe it was just bad reds, but all the greens seem to work very nicely. So if I show you, this is for the pump. He's working nicely. He's for the fan internal, which is still not working, but we can see we've got power on off to the switch. So something down the circuit is not working, and the pump, the little fan over there, is running away, and now it's not running. So everything is working down to that AC to DC converter. So beautiful things are happening here, folks. Beautiful things. I've changed all the red plug sockets on switches for the green ones. They all work fantastically. So I don't know what happened in the first place, but the reds definitely did not work, which is strange, but the greens work. I have undone again my fan and rewired everything. Just took it out, give it a good twist, put it back in, and didn't work. So I decided, okay, well, let's just see what happens if we wire negative and positive the wrong way around. And Shazam! We got us a moving fan, and once again I'm putting my head into a live system. Freaking out a bit here. But, yes, we have a fan. So I have reversed the polarity in this fan. The question is, what way does smoke flow, inside or outside? You expect, if you reverse polarity, that the smoke would actually blow out if the fan reverses, but no, it's blowing in. It's working, guys. It is working. Did you see that? I don't know if that actually worked. Let's get it smokier. Oh, look at that. It works really good. But I have to admit, not a very powerful fan, but it's doing the job. So I'm gonna wire things up again, close it up, and that should be it. Now what concerns me is the last time I connected the whole panel together, I had both supplies connected to the mains, and that is what triggered, well, I don't know if that is what triggered, but that could have been what triggered a malfunction on these guys. So what I'm going to briefly do before I test it again fully is make sure that there's nothing coming in from this mains connected to this mains. There should not be anything connected. Before I turn the other power on, just going to give it a quick test to make sure things are still operational. So system comes on, the Rexes are live, still showing completely different results. Maybe I'm standing up on the thermocouples, but no, they're right beside each other and still 2 degrees off. That's strange. Very strange, maybe. So guess we should plug a light switch in just to see what happens. So does our light come on? Yes. So pump started. That's great. Pump number 2 started. Oh no, it's fan internal. Yeah, I can hear him ticking away there. That's great. Can I feel anything at the bottom? Oh, I really can feel air coming right here. That's really good. Perfect. Number 3, I'm going to turn on my DC pump. He's going to work. And number 4, well, he's not going to turn on until the computer says for him to turn on. Oh, or before I actually put some power in, sorry. Anyway, I'm going to try that now. You'll notice it's a little bit dark, so apologies for that. Let's talk you through it. We got our users here all connected. We have our heating element controlled by our PIDs, which is represented by my lovely lamp. We have our DC pump, as you know, is represented by our shoddily connected DC fan. And our main chugger pump for pumping the wort, 230 volts, connected to our lovely second lamp. 2 PID controllers, 4 switches, which look like they're on. That's why I have the lights off, because yeah, you can see they're off. And our key switches. So what I'm going to do is sort of go through my own typical brew day, or what I expect for a Herms system brew day. Got to turn the panel on, always a good start. And I have been noticing a 3 degree discrepancy in the PT 100s, and they are right beside each other, so maybe there's a way to calibrate them. I'm going to figure that out. The Rexes is a different game, different video. Going to figure that out all by itself. But for now, they're going to serve the function. So all the water's in the kettle. I just turned the brew panel on, and now I'm going to want to start circulating my wort. So I'm going to switch on my DC pump, and you can see it's illuminated and the fan is running. Whether it's running the right direction, I don't know. We'll see that when we pump backwards or forwards. Okay, so the pump's running in the HLT, water is circulating, and then we're going to turn on our main heating element. So going to get our SSRs cooled. That's our fan on the side. He's running. I can feel air coming out the bottom, so the heat is being rejected. That's good. Of course, it would be better if I had it at the top. There's a little hole here, but not much. So we've got air coming out. I'm gonna take my interlock system. So panel is on, everything is controlled, and now we've got the second half of the circuit from the kitchen ready to be turned on. So now the PID controllers. So say one is controlling the HLT. We want that at 70 degrees, and the mash we want it to be 65 degrees. This at the moment is showing that it's controlling 150 degrees, and the actual temperature is 26, so I expect it will come on. The light comes on, heating element on, temperature begins to rise, and we begin to mash in. That's wonderful. So that's all working. We get the temperature of our HLT. It's time to start pumping over to our main mash. So let's turn on our chugger pump. And the chugger pump comes on. So the chugger pump's on, heating elements on, fans on, the fans on, all the lights work, PIDs are kind of happy, but we'll figure that. Oh, it's caught up a degree. As you can see, my extra long PT100 cables, that could be the thing that's gonna be my downfall. But anyway, very, very, very happy. But again, the proof is in the pudding. Now we got to get this guy hung on the wall. And the next video, I hope, will be of the mechanical build.